Right, welcome back to Circular Functions Basics Part 2. In this particular section, we're going to start off by looking at some exact values of circular functions. And in particular, we're going to have a look at some important angles in the first quadrant. Right, let's just quickly go back and revisit one thing before we get started. Right, we've taken a point P on the circumference of the unit circle with coordinates x and y, and we've concluded that the sine value is basically the y coordinate of the point, cos value is the x coordinate of the point, and tan is basically y divided by x. So that's a conclusion we've already made. So with that behind us, let's go ahead and fill out a table of values. Now we're going to look at some basic angles in the first quadrant. So we're going to look at the 0-degree angle or 0 radians. Then we're going to have a look at 30-degree angle. 30-degree angle in the form of radians is pi divided by 6. A 45-degree angle, which is pi on 4. Then 60-degree angles, which is pi on 3 radians, and the 90-degree angle. Now, knowing the exact values of sine, cos, and tan for all these angles is really significant for progress in this part of the circular functions. So we'll start with the 0-degree and the 90-degree angle. So if I go back to my unit circle, right, so I have my 0 degrees there, and I've got my 90 degrees or pi on 2 radians. Now the 2 points in focus is that x coordinate and that y coordinate, which has got 1, 0, 0, and 1. So if I start with my 0-degree angle, sine 0 is 0 and cos 0 is 1. So let's go and fill that out first. So sine 0 is 0, cos 0 is 1. Now tan is sine divided by cos, so 0 divided by 1 is equal to 0. Right, let's go ahead and look at the 90-degree angle. So the 90-degree angle has got coordinates 0 and 1. So sine 90 or sine pi on 2 is equal to 1. Cos pi on 2 is equal to 0. So let's go ahead and fill that out. So sine 90 is equal to 1, cos 90 is equal to 0, and 1 divided by 0 is undefined. So when we go ahead and draw the function for tangent function, we'll later on look at how we're going to represent the undefined part of the tangent function. Now, to look at the 30 and 60-degree angles, right, we need to take into account a triangle. So we're going to take into account a triangle which is the 30, 60-degree, 90 angle. So we're going to have 30 degrees, 60 degrees, and a 90-degree angle. Or in the form of radians, we're going to have pi on 6 for 30 degrees. So 30, 60, 90 triangle. Now the side length for this triangle is going to be 1 square root 3, and the hypotenuse is going to be equal to 2 units. So if I apply my SOHCAHTOA for this particular triangle, I can see sine 30 is equal to opposite over hypotenuse, which in this case is going to be equal to 1 over 2. So sine 30 is going to be equal to 1 over 2. Cos 30 adjacent over hypotenuse, so square root 3 over 2, and tan 30 degrees is going to be opposite over adjacent, so in this case it's going to be 1 over square root 3, or in the rationalized form, it's basically going to be square root 3 over 3. Similarly, if I have a look at the 60-degree angle, so sine 60 is going to be square root 3 on 2. So let's go ahead and fill that out. Cos 60 is going to be 1 over 2. And then tan 60 is going to be sine over cos, which is going to be equal to square root 3. Right, so with that, we've filled most of the table. So all we have got left now is the 45-degree angle. Now to work out the values for a 45-degree angle, we're going to draw an isosceles right angle triangle. So the isosceles right angle triangle is going to have the 90-degree there and two 45-degree angles, and the side lengths are going to be 1, 1, and then the hypotenuse is going to be square root 2. So in conclusion, basically what I mean by that is, to remember the table of values, either you could memorize it, or the easiest way to deal with it is you go to have a look at the unit circle for your 0 and 90-degree angles. Then all you have to do is you've got to remember the two triangles. Right, so this one's the 45, 90-degree triangle. Right, so just with the use of the triangles, let's have a look at some values, right? So sine 45 is going to be opposite over adjacent, so 1 over square root 2. So 1 over square root 2, or in the rationalized form, it's going to be square root 2 over 2. Now cos 45 is going to be exactly the same, 1 over square root 2, or square root 2 on 2, and tan 45 is going to be opposite over adjacent, which both of them are 1, so therefore 1 divided by 1 is equal to 1. Right, so with that information, what we've done here is we've actually filled out the table with the important sets of values, and knowing these values is going to be really critical for the understanding of this particular topic. Alright, so moving on, we're going to have a look at symmetric properties of the circular functions, right? Or the first part of it is to understand when is the trigonometric ratios going to be positive or negative. So to start with, I'm going to go back to the unit circle again. Right, I can't emphasize the importance of the unit circle. Now, if you look at the first quadrant, right, if I look at any values on the circumference of the unit circle in the first quadrant, both the x and y values are positive. Right, so which means sine is going to be positive, right, cos is going to be positive, and tan is going to be also positive. Sine and cos are positive, tan automatically becomes positive. If I have a look at the second quadrant, right, if I take a look at any point in the second quadrant, I'm just going to complete a rectangle. Right, if I complete a rectangle, right, if I take this particular point here, this particular point is going to have coordinates minus x, y. This point is going to have coordinates minus x, minus y, and this point is going to have coordinates x and minus y. Right, so again, going back to the knowledge of sine, cos, and tan. So if we look at the second quadrant, right, the second quadrant, sine is the y coordinate, and I can see that is positive, so sine is going to be positive. Now cos is the x coordinate, and the cos is negative, so we're not going to consider that. And if one of them is negative, tan automatically becomes negative. Now in the third quadrant, sine is also negative, cos is negative, but when we divide two negatives, we get a positive, so therefore the only ratio that is going to be positive in the third quadrant is the tangent ratio. And going into the fourth quadrant, sine is negative, but cos is positive, and sine over cos is going to be negative, which means tan is also negative, right? So, or in simple terms, we can conclude it by just using the words CAST. So CAST basically referring to all ratios are positive, sine is positive, tan is positive, and cos is positive. Now let's talk about some symmetric properties of circular functions, right? So the whole reason why it is important for us to know the angles in the first quadrant is with the help of the values or the exact values of sine, cos, and tan in the first quadrant, we are going to find the values in the second, third, and fourth quadrant. And the way we're going to do it is with the help of this diagram here. Now what they've done here is they've already completed a rectangle inside the unit circle, as you notice. Now, and the angle that point P forms with the x-axis is equal to theta. Now when I form a right angle triangle, when we form the the rectangle inside the unit circle and we draw the diagonals, what I notice here is there are some vertically opposite angles. So if that's theta, this angle is also theta, so is this, and these ones. So they're all vertically opposite angles, therefore they're going to be equal to each other. Now what else I can notice here is, if I take an angle in the second quadrant, right? If I take an angle in the second quadrant, which means this particular angle here, right? This particular angle is equal to pi minus theta. So any angle in the second quadrant, we're going to relate it to the first quadrant in the format of pi minus theta. And in the third quadrant, we're going to relate it by using pi plus theta, where theta is basically the angle in the first quadrant. And any angle in the fourth quadrant can be related to the first quadrant in the format of 2 pi minus theta, right? So that's the most important part of it. So the angle in the first quadrant is theta. The angle in the second quadrant can be related to the first quadrant in the format of pi minus theta, pi plus theta for the third quadrant, and 2 pi minus theta for the fourth quadrant. Right, so with that information behind us, let's have a look at a couple of examples. All right, I'm going to come to the negative angles in a minute, so let's have a look at some examples here. So I've got cos 5 pi on 4. Now 5 pi on 4 is basically a value that is greater than pi, right? So a value that is greater than pi. So what I can conclude here is this angle here, this angle is going to be in quadrant 3. And we've just talked about the relationship between quadrant 3 and quadrant 1. So any angle in quadrant 3 can be related to the first quadrant in the format of pi plus theta. So let's go back to this question again. So I've got cos 5 pi on 4. So cos 5 pi on 4, right? So if I divide 5 pi by 4, I'm going to have cos of pi plus pi on 4. Now in the third quadrant, the only ratio that is positive is the tangent ratio. So which means this value is going to be same as the first quadrant, except it's going to have a minus in front. So minus of cos pi on 4, and cos pi on 4 from the table of values is 1 over square root 2. So which means the exact value of cos 5 pi on 4 is going to be minus 1 over square root 2. Right? Similarly, if I have a look at sine 11 pi on 6, so sine 11 pi on 6, right? Sine 11 pi on 6 is just slightly below 2 pi radians. So which means this is going to be in the fourth quadrant. So we can relate it to the first quadrant by going 2 pi minus pi on 6, right? And in the fourth quadrant, the only ratio that is positive is the cosine ratio. Therefore, the value of this sine angle is going to be a negative answer. So which means negative sine pi on 6, and negative sine pi on 6 is going to be equal to minus 1 over 2, because sine pi on 6 is 1 over 2. Right? Similarly, we can locate other values. Now, let's have a look at this one here. Cos 200 pi on 3. Right? The first part I'm going to do is I've got to decide which quadrant is this going to fall under. So the first thing I'm going to divide 200 by 3. So if I divide 200 by 3, right, I'm going to have 66 pi with the remainder of 2 pi on 3. Now 66 pi is basically 33 rotations on the unit circle, right? And remember, when we talk about sine and cos, we basically get back to the same value after every rotation, right? So this is same as writing cos 2 pi on 3, right? And cos 2 pi on 3 is an angle inside the second quadrant, right? So second quadrant, we can relate it by going pi minus theta. So I'm going to have cos of pi minus pi on 3, right? In the second quadrant, the only ratio that is positive is sine. So therefore, this answer is going to be minus of cos pi on 3, and cos pi on 3 is square root 3 on 2, right? So ultimately what we try and do is we try and relate the angle to an angle in the first quadrant. Then we have a look at the 4 quadrants. In specific, we have a look at CAST and determine whether the answer is going to be a positive answer or a negative number. Alright? Right, let's have a look at some negative angles, right? We've talked about negative angles. So positive angles is measured in the clock or anti-clockwise direction, right? And when we measure an angle negatively, it's basically in the clockwise direction, right? So sine of minus theta. Now sine of minus theta is going to take me into the 4th quadrant, right? And in the 4th quadrant, the only angle that is positive, or the only ratio that is positive, is the cosine ratio. Therefore, this answer is going to be same as writing minus of sine theta, right? Because again, if we take the coordinates again, right, the 2 coordinates of that point, this one's x, y, this one's x and minus y, right? And that minus y is basically telling us that the sine value is going to be negative. So that's why we have sine of minus theta is equal to negative sine theta. On the other side, cos of minus theta, right? Cos of minus theta is again going to take us into the 4th quadrant. And in the 4th quadrant, the only ratio that is positive is the cosine ratio. Therefore, cos of minus theta is equal to cos theta. And finally, if sine is negative, automatically makes tan negative, so therefore tan of minus theta is equal to minus of tan theta. Right. I'm going to stop with this lesson at this particular point. There is going to be a 3rd part talking about a few other things. So thank you for watching, guys.